We're recording. Please stand. Right. And let us pray. In nomine Patris et Filii et Spiritus Sancti. Amen. Sancta Michael Arcangelo, defende nos, previo, contra nequitiam et insidias diabolum, est presidium, impere Filii Deus, supplices te precamo, tuque princeps militiae celestis, Satanam, aliosque spiritus malignos, qui ad perditionem animarum navigantur in mundo, divina virtute, in infernum determinum. Amen. In nomine Patris, et Filii, et Spiritus Sancti. All right. There is. I usually put them in the playlist, yeah. There's a playlist for calculus, and our video should be in there. Yeah. And like the ones from last week and such, they're in there. Yeah.
But what about like last week's class?
If I didn't delete them, yeah, they're still there. So you could theoretically travel back in time and see the pre-calc ones. I don't know how many calculus ones I actually recorded. If you want to see what last year's calculus class looks like, feel free. It's public domain.
Oh yeah, wait, did you know we can start doing some recording?
Yeah.
Yeah.
So, does everybody have a copy of the 2K, as in kangaroo? All right, let me see what you have.
How many subscribers do you have?
I have no idea. I think like 2.
We should know, like and subscribe.
Yeah, I have no idea how many likes. Y'all heard about the guy from India who
Yeah.
subscribed to you.
Very well.
Like,
Wait, what? So this guy from India commented, he's like, very well explained, sir.
who are you?
Who are you? I love how like this guy's listening to us talk in class all the way from India. He's like actually learning with us.
How close were you?
It was pretty close.
You were driving your car around by the gravel, and then you got up towards the driveway, and somebody was standing there, and I was like, guys, watch out, Michael's car's coming through. And I was so bad. My mom was right there, and we just started cracking up, and it was terrible.
You just remember like,
Oh, I was just like, holy crap. It was I light out right there. And I was like, holy cow. I said, like, oh, I was like, oh.
All right, 2K.
So bad,
For
dude.
people listening at home, hi y'all. I miss you. We're going through homework 2K, as in kangaroo. And the answers are as follows. Have a right writing utensil at the ready. So we got. Number 1. Everybody has a writing utensil ready to correct their work. Preferably red or something of a different color than what you actually did the worksheet in. I have red pens over there if we must. Number 1, negative radical 2. Negative radical 2. Number 2, no limit. Number 3, positive infinity. Number 4, no limit. Number 5, limit is 2. Number 6, the limit is negative 1. Number 7, the limit is negative 5. Number 8, the limit is negative 3. Number 9, the limit is negative 7 over 2. For people addicted to decimals, negative 3 and a half. Number 10, God bless you if you typed that in correctly. I think we did that in class. Okay, good. So, negative 2. Number 11, the limit is 2. Number 12, remind me, I've got a by hand way to show you on that thing. Number 12, limit is 1. 13, the limit is -1. 14, the limit is 0. 15, the limit is 0. 16, the limit is 1 over 5. 17, the limit is 0. 18, the limit is 1. And it repeats.
Can you repeat 14?
14. 14, the limit is 0. Any other repeats? Yeah.
You go over like most of the packet. I got like all of them.
Okay. Yes, I'll go through as many as you like. But somebody remind me, I need to show you how to do the absolute value problem by hand. There's a way to do it by calculator, but it's actually quicker to do it by hand if you know the trick. All right, I'm opening up to questions. Pick one. Don't do all, just pick one. We can do more than one. Where do you want to start? Okay, fair enough. Number 1. Yikes. Got the order of operations splattered all over. Now, if you want to do these by hand, and by the way, doing the number 1 on a calculator, did anybody get -1 point something, -1.4, -1.5 thereabouts? Yeah, that's not incredibly bad. That's close to the decimal for negative radical 2. Yeah.
So, yeah, I guess I have a question about that. So I got the decimal and I didn't realize that it was the square root of
Right.
2.
Depends how accurate you got it. Did anybody get close to -1.414? I would accept that. For the purposes of the test, I would accept that. How many decimals do I want? Places do I want? 4. 4. I should assume 1.4142, I should say. Yeah, would be ideal. In this particular one, it was complicated enough that I might cut you some slack and give you the 3 decimal points for being okay. Let me show you this. The limit, as x approaches pi over 4, that's an overall limit of negative secant of theta of x. So used to sec theta. What is secant? Oh, math people. Or trig remembering people, go. It's a reciprocal of cosine. So you can do this instead. The limit as x approaches pi over 4 of -1 over cosine of x. Now question, can we plug that in? The only time we couldn't plug it in is if cosine turns to 0. If you plug in pi over 4, is that 0 or no?
I know it.
Does anybody remember, what's pi over 4 as an angle? What's pi? Pi is in radians. What's the degrees? Take a stab guess, go. 180. Memorize that. Pi is equal to 180 degrees. So what's pi over 2? 90. What's pi over 4? 45. This is 45 degrees. That's a common angle. You should remember the cosine of pi over 4. What is the cosine of 45 degrees? Oh, math people don't remember their trick. What shape could give you the answer if you got stuck? Unit circle, definitely. Also, yeah.
The 45, 45, 90, right?
The 45, 45, 90 triangle. What is the cosine of 45 degrees? Maybe we better drill some of those trig things again. Go.
1 over radical 2.
1 over radical 2, which repairs to what?
Radical 2.
Yeah, radical 2 over 2. I'm actually going to leave it as 1 over radical 2. We're going to enjoy our newfound freedom here. So it should be -1 over 1 over radical 2. To simplify. It's actually not too bad to simplify this. Polly, help me out here. What would you do?
So for the denominator, do you have
Is it
to take out the radical? Or
You could, although in our class we don't have to. I'm just noticing there's a fraction in the denominator. When you divide by a fraction, how do you do that? By the reciprocal. What's the reciprocal of 1 over radical 2?
Is it just radical 2 over 1?
Give me your final answer.
Negative radical 2.
Yeah, and the over 1 doesn't do anything, that's your answer. So that's how to do that without a calculator. So it is possible to get the exact answer on that one using your trig knowledge from last year. So on this particular problem, I might actually take off, if I put this on a test, I might actually take off points. It would give me negative 1.414. Just because this is relatively easy. If it's one of the gross ones where if you plug it in at 0, then I'll cut you some slack. Because sometimes you have to use the calculator as far as you know. Next. Okay. Michael, I'm gonna have you do, yeah, question.
May I go to that?
Yeah, right back. We have the limit as x approaches -2. Is number 2. Again, it's an overall limit. What was it? -3 over 8. You notice the negative is in front. I'm gonna put it in front. In front of the 3. I'm gonna put it up on top. Question, Michael, did you plug in?
So what I did is I got vertical asymptote at -2.
That is correct. In other words, you went through the first 5 methods and none of them worked. Can't plug it in, nothing to factor, no common denominators, no radicals. Squeeze theorem, what the heck is it? I haven't told you yet. Therefore, graph it. And there's a vertical asymptote at x equals -2. Question, single, double, triple? Single. What does that mean for the graph? If you have a single asymptote, how does the graphs work? Do they go both the same way? Correct. They go one way, one goes one way, one goes the other. Which one is which? One on the left is going up? That's correct. And where else does it flatten out?
The x-axis.
Yes. It flattens out at the x-axis, and then the other one goes like this. That's really all we need. Is there an overall limit at x equals -2?
I said infinity.
Infinity is if you're approaching from the left-hand side. What if you're approaching from the right-hand side? Yeah. Remember, the answer to a limit problem is the height. It says, as x approaches something, what is y approaching? That's the answer to a limit problem. So, if they said x approaches -2 from the left, you'd have an answer. If you had from the right, you'd have an answer, negative infinity. But if they want an overall limit, the only time that exists is if both sides what? Anyway, agree. If both sides agree. If they were both going up, I'd say, okay, you got an overall limit at positive infinity, because they're both going up to infinity. If they were both going down, I'd say, yeah, they agree, you have a limit at negative infinity. If they were both aiming to a height of 5, I'd say, okay, you have a limit of 5. But this thing, one goes one way, one goes the other, they don't agree, take its toys away. They can't agree. So there's no overall limit. Okay. Next. Anybody else want to throw their hat into the ring here? Yeah.
Are you number 7?
7. Yeah. Oh yes, I get a chance to show you the by hand method. You might want to grab your notes for a second. This is the method of doing the absolute value ones by hand. Again, I'm not forbidding you to do a calculator. And this one on the calculator is not too bad. But it is dependent on being able to zoom properly. The x approach is 3 from the left. Of 5x minus 15 over absolute value of x minus 3. So, question, can you plug in? Forget it. Can you plug, yeah, can you plug in 3?
Oh, no.
No, it explodes. Is there anything to factor?
You could do a GCF.
You could do a GCF, what is that?
Pull out 5, it would be x minus 3.
Good, over absolute value of x minus 3. Question, can I cancel those? No, you cannot. Here's where we kind of get stuck. You can graph it on a calculator at this point, or the original one on the calculator. And it should look like this. This is how I expect you to do it on this one. I'll show you the other method in a minute. But I'm going over to 3. At a height of 5, it should look like this. And at a height of negative 5, it should look like this. So that's what the graph would show up on your calculator. And you're approaching it from the left, which means this. So what's the limit? Right there. Deal decision. Negative 5, correct. Does that make sense? That's how to do it on the calculator. I am going to show you a trick of how to do the absolute values by hand. In your notes, you might want to write this down. Definition. You remember that in years past, I asked for the definition of absolute value. Anybody remember it? You can actually do it in 3 words. What's the definition of absolute value? Yeah.
All positive outputs.
That's right. It does have all positive or 0 answers. But how do you get it? Where does it come from? Think of a number line.
Does that have something to do with like how far the number is away from 0?
The distance from 0, correct, exactly. An absolute value is the distance from 0. That's the casual definition. I'm about to give you the sort of college technical definition of absolute value. The absolute value of x is equal to a piecewise function. It has 3 parts. It's equal to x if x is greater than 0. It's equal to 0 if x is equal to 0. It's equal to negative x if x is less than 0. That is the college technical definition of absolute value. It's a 3-way piecewise function. We've had piecewise functions for a while, so hopefully this is not yet scary. But try this out. Like if you actually have the absolute value of 3, which category would activate? The top, the middle, or the bottom? The top. So what would you use as your answer? What did you plug in? 3 for x. So what are you going to use as your answer? Yeah. So in other words, what does the top give you as an answer? That's the condition. That's when you use the top. 3. Like these are your answers. And these are the conditions when those happen. In this case, use x. So it's 3. Try this. Absolute value of negative 5. Which one activates now? B. Which of these 3 activates now for absolute value of negative 5? The bottom. So what would you use as an answer? Like, what are you plugging in? Negative 5. So what do you have as an answer? Yeah, negative x, which is negative 5. In other words, if you obey these, you'll always do the absolute value. negatives, basically say if the answer is negative, it'll switch the sign. If the answer is positive, it will not switch the sign. And if it's zero, it's zero. This is the technical definition of absolute value. Why should we care? It seems like a complicated way to mess up a nice problem. Well, I don't know about you, but I was a little bit annoyed at the fact that we couldn't cancel anything over here. If only these things had been parentheses, we'd have canceled, and then it would have been 5. It would have been great. Watch this. Question. Are we approaching, well, basically, is x minus 3 positive, 0, or negative when you do this? Can you picture this in here? Like, here's what we're doing. Now I know that x eventually gets positive. It's going to be close to 3. What happens to x minus 3? Is that value positive, negative, or 0 as you do this? Yeah, it's negative. Does that make sense? This is going to be like negative 3, negative 2, negative 1, and you eventually get towards 0. But it's going to be negative, 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 negative. You get the idea. I can't say that too many times in a row. It's a hard word for me to say. So it's going to be negative. This thing, by definition, absolute value of blah is negative blah in this case. So I'm going to rewrite this since the blah is negative. I'm going to do this. The limit as x approaches 3 from the left, 5 x minus 3, negative parentheses x minus 3. You see what I just did? I just copied and pasted this. It's the negative thingy. Whenever, if you know that the thingy is negative, absolute value says replace it with negative thingy. This is thingy, x minus 3. That's negative, you said, so I'm replacing it with negative thingy. These cancel. 5 over negative 1, negative 5. Yeah. If I had come from this side, if I had the limit as x approaches 3 from the right of 5 parentheses x minus 3 over absolute value of x minus 3. If you're coming from the right, is x minus 3 positive or negative? Jack.
Can you repeat the question?
If I decided to go approach x is 3 from the right, then is this value positive, negative, or 0 as I do that? Like x is going to be like 6, 5, 4, 3.
If you approach
But what does
it
x
from the
minus 3
right,
do? Is that going to be positive in that journey, or negative, or 0?
It would be positive.
Positive, because when you're at 7, 7 minus 3 is 4. It'll be 4, 3, 2, 1, and the lowest will go 0. So it's going to be positive. What are you authorized to replace this with if you know that x minus 3 is positive? Which of these 3? The first one. In other words, the absolute value of blah, if it's positive, you can just rewrite it as blah. And those cancel, and the limit would be 5. Does that make sense? Okay. I'm not taking away from you the ability to do it on the calculator. I'm just saying if your calculator fails you for some reason, be it batteries die, or the charge fails you, or somebody eats your calculator or something like that, you have another method. Next. I do want to hear from other people. And you're welcome to have more than one, but go. Number 8. Yeah, there's another piece wise. Is everybody good on this one? Right up here? Can I erase this left-hand side stuff? The limit as x approaches 1 from the left is number 8. And again, make sure this is not x as approaches negative 1. It's not. X approaches 1 from the left. It's a piecewise function. Negative x over 2 minus 5 over 2. They should have put the word if, but the condition, if x is less than 1. The other one is negative x squared plus 2x minus 1 if x is greater than or equal to 1. Now again, did you want to do this on the calculator or do you want to do it by hand? It's up to you. By hand? Okay. Now by hand, you'll have to graph this by hand and this by hand, which is not horrible. I'll show you what it looks like. As long as you're comfortable graphing lines and parabolas, this won't be too hard. You can always plug it into a calculator to double check your answer. That's usually pretty smart. So I'm just going to rewrite this. This is y equals negative 1/2 x plus negative 5 halves. That's the graph. And then the graph here is y equals negative 1x squared plus 2x plus negative 1. Let's see what those look like. The first one is slope-intercept form. It's a bit obnoxious because it has a decimal for y-intercept. A fraction. So negative 2.5. And the slope is up 1, well actually down 1, right 2. So down 1, right 2. Down another 1, right another 2. Okay. Question, no math people, look up here. This is a proportion test, first year algebra question. If you're going down 1, right 2, what if you go down 1/2? Have you got what I asked? If you're going down 1 and right 2, what if you go down 1/2? Yes. To the right 1. That will help to get a couple extra dots. Down 1/2, right 1. Down 1/2, right 1. Okay? So you actually had a height of negative 3 when you hit the x equals 1. So here's the line. I'm going to make a very, very faint graph. Can anybody tell me where that line exists? Max, take over.
Sorry, what's the question? I was working.
Okay. Make sure you plug into this because I'm explaining how to do these things. What part of that line exists? When does it start existing? Second?
I don't know.
Okay. Here's the condition. Here's the line. Here's the condition when it exists.
At 1.
Okay, and what side of 1?
Or negative.
Well, which side, left or right?
Left.
To the left. If x is less than 1, this line exists. Is everybody getting the idea of how piecewise functions work? Everybody look up here. To unplug from your calculators for a second, especially if you're not doing this. Now, the limit of blah, 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 this function has two personalities. It behaves like this when x is to the left of 1. It behaves like this parabola if x is on 1 or to the right. Does that make sense? So here, I'm going to do an open dot and darken over here. There's half your graph. This thing, you'll need to know how to factor or complete the square or something to to get this thing graphed. This actually does factor. It's negative 1 parentheses x squared minus 2x plus 1, which actually turns into negative 1x minus 1 parentheses squared. I played with it earlier. So this thing factors by binomial squared and by GCF. So you can actually see the vertex now. The vertex is at 1, 0, and it's upside down. A little dot here. And it has a normal height, over 1, down 1, over 2, down 4, and 4 should look like this. Oops, that wasn't the right point. Sorry. Okay. Got one here, close. This one, 2. Oh, that was right. 2 and then 4. Which part of the parabola exists? Polly.
Anything to the right of 1 or including 1?
Yeah, would that include 1? Yes. So here, solid dot, and everything to the right. You'll notice there's a break. We talked about this I've never actually played with one before. Calculus is the first time we're going to see them. It's called a definition break. This is a place where the graph actually snaps. So it's not connected. If this had been only up a couple of spaces, it would have been continuous. They would have joined. But this is discontinuous. So they want the limit as x approaches 1 from the left. You tell me. Michael. If you're approaching x equals 1 from the left, what shape are you on? Are you on the line? Are you riding down the line, or are you riding down the parabola? Do you understand what I'm asking? Are you guessing? Well, for example, x is approaching 1 from the left. Here's x equals 1. I'm coming at it from this side. What piece of the graph exists over there? The line or the parabola?
Oh,
The line. So anytime you see a solid graph, hop on it. Here's what the limit is doing. Getting closer and closer to what? Right, because does it ever get there? No. So it doesn't care whether it's actually has a landing spot. It just wants to know, where are you aiming? Negative 3. That's your answer. Any questions? Any questions? Again, you could do this on a calculator, but again, the only way a calculator would help is if you graph this and see what happens there.
You said there was a way to.
You might not thank me, but today I can show you how to do piecewise functions on a calculator. Grab a calculator, so I'll show you. Actually, I'll keep this up so you can compare it. Go to the y equals screen. We're actually going to use y1 and y2. y1 we're going to do for the top one. y2 we're going to do for the parabola at the bottom. Now I'm going to give you a piece of code that's built into the Texas Instruments calculator. Computers don't do this. Computers have other ways of doing it. Like I have a graphing program on there it's actually a lot easier to do, but that's because you actually have a keyboard and you don't have like limited data. So y1 should be this. Do this. This is absolutely important. Start with parentheses. That's part of the code. Start with parentheses and then type in -1/2 x. Now, this looks like -1/2 x. What does the order of operations turn it into? Will this register as 1/2 x, -1/2 x, or -1/2 x? You tell me. Oh, calculator using people. It's nice to know what the calculator actually does.
The ladder?
The latter, this one. How come?
There's no parentheses around the two numbers.
Right. It does the order of operations. Divide and multiply are the same range, so it does them in order. It'll do -1 divided by 2, then multiply it by x. So it does not do this unless you put parentheses around the 2x. Good. So -1 of x plus -5/2. Close parentheses. Then open a new parentheses immediately after. This looks like we're about to multiply by something, but it actually won't if you do this properly. Type the letter X. I'm about to introduce you to a new menu. In the upper left-hand corner, you'll need to use the second key to get there. Look for a menu that says Test. Test. Let me grab mine. It should be right above the math key. Once you get there, tell me what you see. There's two columns. There's one that's called Test and one called Logic. Don't do the logic. That's fun, but completely different. What do you see?
Equal, not equal.
Equal, not equal,
Greater
greater than or equal to, less than or equal to. We're about to do this. The condition on this was x is less than 1. Select the less than sign. I believe that's choice 5. And then select 1 and close parentheses. Now the fact that it's just a little calculator means that the graph is going to be kind of limited. The graph and calculator, what it does is it basically has a pen and it draws whatever the height is that it calculates. It plugs in a bunch of x's, calculates the y's, and draws up and down. This thing is actually a little stupid in the sense that if there's nothing that exists over here, it'll draw it at 0. It'll draw a horizontal line, and it's not supposed to. So what you're going to see on the left-hand side, go ahead and hit graph. You'll see a graph where the line goes down, 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 then you'll probably see a smear, and then a line following the x-axis. That smear and the x-axis line is not supposed to be there. Just the graph doesn't know what to do. If you have a particularly smart new calculator, maybe they fixed that, but they didn't last time I checked. Let me double check to see what that looks like. Yeah, that's exactly what we're talking about. Yep. If you have a black and white one, then you have a little bit less. It's a little less obvious to see. But if you have like a blue line or a red line, it's really easy to see. Now, go to Y2. Go to the Y equals screen, Y2. Open with parentheses. That's absolutely imperative. If you don't have parentheses around the entire function, then this thing on the right-hand side will only apply to this. And that's not good. I think it'll even give you an error. So type in -x² plus 2x minus 1, close parentheses. And then new parentheses with the condition on x. X, then in order to get this, you do the test menu. It's the second math. So go to second math, and then look for the greater than equal to sign, which I think is choice 4. And then type 1, close parentheses, hit enter. Again, it's not absolutely beautiful. If TI people had been just a little bit more neat, they could have just deleted the extra pieces. But the parts that are curving, just out of curiosity, do you remember how to turn off the connectedness? It's on mode. Go to mode, you see connected versus dot. Go ahead and select dot. I'm just curious what the new calculators are going to do with this. Yeah, I mean it has a disadvantage because it actually does a dotted line, but it's a little bit less lucky. Any questions on that? That should give you a graph that approximates this. You will have to eyeball it still and do the answer yourself. I will show you something for fun though. Let me type in the, so we've got parentheses, -0.5x minus 2. And then the other one was parentheses negative x squared plus 2x minus 1. Close parentheses, new parentheses, x 4. Oops. 1. Okay. So if you did a zoom standard, again, you should have a smear kind of like this. Oops. Y equals negative x squared minus plus 2x minus 1. Okay. Hit trace. Go to the graphing and hit trace. What do you see? Well, like at the top of the screen. Somebody raise your hand. What do you see? Describe it for me. Pete, what do you see?
I just see what type of
Y1. It says Y1 equals parentheses, blah, blah, blah. What does it say on the bottom? Pete, sorry, Jack.
Well, if you hit trace, it says like x equals 0, y equals 0 start, I think.
If you hit trace, it shouldn't say Y equals 0. It should say Y equals something else.
Well, it depends on what point you're, I was working on a different graph.
Oh, right.
So,
If you're working on this graph, you'd have x equals 0, y equals negative 3.5. Accurate? Everyone, please hit the up arrow. Correct. Oh, interesting. Yeah, you were scooted over a little bit. That's fine. Actually, tell you what. Hit trace and then type the number 0 and hit enter. Do you get 0 coming negative 3.5? Okay. Now, while you're still on trace, hit the up arrow. Tell me what you see. What's going on?
X equals 0, y equals 0.
X equals 0, y equals 0. What's up on top?
It's the second.
It's the second formula. Hit the up arrow again. What do you see? Okay. Goes back and forth. If you just keep hitting up, it'll flip back and forth between those two. So if you have like 8 different graphs, you can go up through Y8, Y7, Y6, Y5, Y4, and it'll jump to that graph and tell you where it is. Now, use the right key. Go to the, make sure it's Y1, hit the right key again and again and again and again and again. What happens? As you get past x equals 1. Yeah, what's the height? 0. Now hit the up arrow. I have like 4 point something, comma negative 10 point something. Do me a favor. Does everybody have Y2 on the top? If you don't, hit the up or down arrow until you get Y2 up on top. Now, hit trace. Make sure it's Y2. If you hit trace again, you might have to hit the down arrow to get to Y2. And now type in the number 3. Tell me what you see. Again, typing in a number sort of hyperwarps your calculator to that point. What does it say, Michael? By the way, people listening at home, here's the, I hope it's clear. I don't know if you can see all of it, but that's Y2. There's a line going down here, and then a parabola going down here. Hopefully it looks like the same as up here. What did you say, Michael? Let me look. First of all, let me see
Y
Y.
equals negative.
Are you on the same part? You're not on the same part. Okay. That's part of it. Does anybody still have the same?
Isn't it negative 3?
Okay. Does anybody else still? Okay, good. What did you have? Hit the down arrow. You're on Y1. Good. Now hit 3. So it jumps to x equals 3, y equals whatever. So 3 comma negative 4, roughly. Are you like at negative 3.9, blah, blah, blah? Or is it negative 4? I didn't. Okay, that's calculator error. It's pretty much negative 4. All right, summary. If you want to plug in a piecewise function and try to get the calculator to eliminate the non-existent parts, do this. If you want to just eyeball it and just try and ignore the correct parts, feel free to just type these in. I would recommend that you know how to graph these by hand. You should, at this point, know how to graph a parabola by hand. You definitely should know how to graph a line by hand. Questions? Okay, thanks. Got about 3 more minutes, so yeah. Number what? 13. This might be the last one we do for today. Yeah, number 13. And just so you're aware, there is no new homework tomorrow. Merry Christmas. Wednesday, there's going to be a practice test. Thursday, there's going to be going over the practice test. That wasn't good English, but you know what I mean. And then Friday is the actual test. So start prepping there. Everything we've covered on limits so far is fair game. I'm not going to make a horrible brain buster of a test, but it will require that you know all the stuff that we covered. You will not need to know the squeeze theorem. I'll tell you that tomorrow, by the way. That is actually going to be an extra credit question about the squeeze theorem. So question, Max, is this a left limit, right limit, or overall? First of all, overall, correct. Where's x approaching? Can you plug it in? Why not? Right. It would be 1 over 1 minus 1, and so the entire big fraction would have a 0 on the bottom. Blows up. What's the solution of this? What method? What's the very first thing? Plugging in is the first, doesn't work. What's the next option? Before coming down there. By the way, that's the one that works. Factoring. No factoring. So then we go to common denominator. Here's what I do. I add the opposite and put a 1 here. Then the common denominator, you can do crisscross across if there are only 2 fractions. So it's going to be the limit as x approaches 0 of the x on top, and then I want to get a common denominator here. Whole fraction. Tune in, Joe. Criss cross is now -1 times this stuff. This is -1, whoops, plus -1x. And on the bottom is 1 times this stuff. 1 plus x. Does that make sense? These cancel. So you're left with the limit as x approaches 0 of x over -1x over 1 plus x. Or x plus 1. How do you handle that? Pete, take over.
So, well, you have a fraction in the denominator, so you have to get that out.
How?
Could you multiply the bottom by the reciprocal to get 1, and then multiply the top by the reciprocal of the bottom?
I like the word, that's kind of overkill. When you divide, you're dividing x by a fraction. How do you do that? When you divide by a fraction, you
have.
how do you divide by a fraction? In general. If you're dividing by 3/5, how do you do that? Like this. How do you do that?
Like, how do you get rid of it?
No, how do you actually get the answer?
You have to multiply the top by the bottom, or
By,
the bottom. It's like, you have to multiply the top by 5 over 3, right?
yeah. In other words, this is gone. You don't multiply by the reciprocal on top and bottom. You just multiply by the reciprocal, period. Dividing by a fraction is multiplying by the reciprocal. Same thing here. It's going to be this multiplied by the reciprocal. And when you do that, the x is canceled. You're left with the limit as x approaches 0, 1 plus x over negative 1. And then plug it in now. Michael. Yes, do it. Yeah, it's going to be 1 over negative 1, which is negative 1. Make sense? That is all the time we have. We can continue doing this tomorrow. I would like to finish off anyone that you'd like to see if you're still stuck on it. Then we'll start giving you general review for Wednesday. Practice test will be the best review. So we have that on Wednesday. Plan for taking all hour. And so, please stand. Let us pray. In the name of the Father, the Son, and of the Holy Spirit. Amen. Glory be to the Father, and to the Son, and to the Holy Spirit. As it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. One other thing, if you like the definition of the absolute value escaped you today, you can go back and view the video over and over and over again if you need to. So by the way, people, if you get home, bye-bye, see you soon.